Okay. Factoring by decomposition, but more importantly, this is actually a problem-solving question about quadratic. So it says a pentagon has two sides that are equal to each other, and another three sides that are equal to each other. The perimeter of the pentagon is expressed by 14x squared plus 6x plus 5. If the three equal sides measure 3x squared plus 5x plus 1 each, what are the dimensions of the other two equal sides? So let's try to make sense of this from the drawing. It's a very terrible drawing I've made. But think of this as like, here are your two sides that are equal, and then these would be your other sides that are the three sides that are equal. So we know those three sides. Oh, I should have done the colors the other way. Oh well. The three sides, they all add up to that expression here. So the question they're asking us right now is, what do these two sides add up to? What are the dimensions of the other two equal sides? Okay. Well, we know that this part's taken care of because this is a perimeter. So, perimeter is equal to 14x squared plus 6x plus 5. That's great, but we need a better visual here. What if we were to talk about how we're just going to call this S and S, because those are each a side, and then I'm going to call these ones, I don't know, X, X, and X, okay? We're focused on the two sides right there. Because it's perimeter, we know we're adding those all together, so we're actually going to use letters instead of numbers right now. So we know the perimeter of this pentagon is actually S plus S plus X plus X plus X. And we already know we can simplify those x's, right? And we can simplify those s's. So the perimeter is equal to 2s, right? Does that make sense so far? Plus 3x. Well, we actually already know what 3x is equal to. 3x is equal to this information right here. 3x squared plus 5x plus 1. So we can actually substitute. We can get rid of the positive 3x here and substitute this information in for it. So why don't I shrink some of this, because this is a lot of info. Okay, and let's do that. We'll go here. Perimeter is equal to, we still don't know the 2s. They're unknown to us. But we can add, and I'll put it in red over here, 3x squared plus 5x plus 1. Good. So we got some information here. We just don't know what the 2s is. Okay? Do we know what perimeter is? Well, yeah, actually, perimeter is equal to that information there. So we can put that, we can substitute this information in for the p on this side. And then we're going to have a really long expression, and the whole goal will be to isolate the 2s. Does this make sense how I'm setting it up so far? Yeah? Okay. So, let's highlight that. We're going to replace this perimeter with 14x squared plus 6s plus 5. So, 14x squared plus 6x plus 5, that's the perimeter of the pentagon, is equal to, well, we have 2s, that was one of our unknowns, and then what the other three sides are equal to, they're equal to 3x squared plus 5x plus 1. Let's put these in brackets. Now, we don't technically have to, but think of it like the 2s is representing those two unknown sides. This set of brackets here is representing those three sides we know, and this is representing the whole perimeter. Okay? I'll shrink that a little, and we'll put it up. Give ourselves a little room. So, over here, what we're going to have, actually going to talk to it, the whole goal will be to isolate 2s. We want 2s by itself on one side. So the reason I put this in brackets is because, you remember, I said that it was a plus here. Well, we don't want it on the same side as 2s, so we're going to move it to the other side. So when we do that, we are technically subtracting both sides by an entire expression. So I'm going to move this over and put a subtraction sign in front of it when it goes to the left side. So how's that going to look? Well, we're going to have 14x squared plus 6x plus 5. Have that set of brackets. We're moving this over. So now think of it as minus 3x squared plus 5x plus 1 is equal to 2s, whatever 2s is. And now that I think about this, we are not going to be doing any decomposition. It's okay, we're going to be problem solving, so let's get rid of that part of the title. There's nothing in front here to distribute, so we can just essentially drop that set of brackets. But because there's a negative sign in front of this set of brackets, think of it as if you're multiplying by -1 each of the terms inside of the brackets. Does that make sense to you?
But it says that is of each, so does it mean that's just
if the three equal sides
side?
measure... Oh, you're
So
right.
isn't it 3?
Okay, so 3. So great. Even though we made a mistake, that's a great observation you made, we can say -3. Excellent save. Otherwise, we're going to get a really funny answer. So let's multiply that through and find out. So the very first part, we're just going to drop the brackets off. We still have 14x squared plus 6x plus 5. Now we're going to multiply -3. And so when we multiply -3, we'll get -9x squared minus 15. Perfect. Minus 3. Makes a lot more sense. I was wondering how they got the one constant. Oops. Okay, and that's still equal to our 2s. Well, let's collect our like terms here. We have our x squared minus 9x, that's going to be a like term. We have our 6x and our -15x, that's going to be a like term. And we have 5 and -3, those are going to be a like terms. So, first in green, 14x squared minus 9x. Any idea?
5x.
Yeah, 5x squared. Perfect. 6x minus 15x.
-9.
Perfect. -9x. And then finally, 5 minus 3?
2.
Positive 2. Okay. I'm going to write that all in black just so it's a little more permanent and looks easier to see. 5x squared minus 9x plus 2 is equal to 2s. Well, the goal is still to isolate just s. So we are going to divide both sides. Oops. Divide both sides by the number 2. So when we divide this all by 2, we can just write it like that if we want. And we can technically say that s is equal to all of that. But then that's both each individual side. You can say 5x squared minus 9x plus 2 divided by 2. That's technically each side. Or you can divide each term by 2. So we can say the letter O, or the word or is equal to s. And we could say 5 over 2x. And you can make that like 2.5 minus 9 over 2x. That's technically negative 4.5 plus 1. Each side is technically equal to that in this question. Okay, is that what they ask us? What are the dimensions of the other two sides? Yeah, that's the dimension of each of those two sides because we divided by 2 at the very end.